Hi guys, this is Dr. Arthy, associated with Kamaraj College of Engineering and Technology as an associate professor in the Department of Information Technology. In this video, we are going to look into the concept which is very familiar in graph, which is called as minimum spanning tree. So before we move in depth into a minimum spanning tree, let us explore a small part of graph which will be a recap of whatever things that is required for minimum spanning tree. So looking into graph. So graph is a nonlinear data structure which is a collection of nodes and edges. That is, we do have a graph G which is having two things in it. One is vertex, the other one is edge, and this vertex is called as nodes. So whatever we say as a vertex, this is called as node. Now let us take a small example of it. So let us have a graph like this, where we have three nodes here. So all these things like A, B, C, all these three are said to be nodes. So every node in a graph is represented with circle, and the connection between nodes are called as edges. So looking into a graph, we do have here as three nodes, and each node are connected with edges, right? So here we have three different edges. And as of this graph is considered, this graph is a unweighted graph. Why this is called as unweighted graph? Because we don't have any weights in the edges. If any graph is having a weight, then it is called as weighted graph. For example, if I am giving here as 10, 25. Now what happens? This graph become a weighted graph. That is, on traveling from the node A to B, it takes the cost of 10. So this edge is speaking something in addition called as cost. So that is what called as weighted graph. And one another thing with this graph is, this is an undirected graph because the flow of direction is both sides. Anyone can travel from A to B or from B to A. So this is called as undirected graph. Why all these things are mandated before looking into minimum spanning tree? So speaking about minimum spanning tree, we are going to take graph into consideration, and in specific we are going to speak something about the weighted graph that would be better and more interesting in case of minimum spanning tree. That is the reason why we had the overview of what is graph. So what we said is, graph is collection of nodes, and each and every nodes are connected with edges. All the circle are said to be nodes, and the connection between those two circle are called as edges, and the graph can be a weighted one or an unweighted one. Speaking about a weighted graph, if we have some cast in its edge, is called as weighted. If it is having a flow of direction, then it is called as directed graph. If there is no flow, then it is called as an undirected graph. Okay, so we have explored what is graph and what are the categories of graph. Where this graph is used? Mainly the graph is used in order to tell something about finding the shortest path, how to reach in a very short distance from one place to another place. So in that specific case, we are going to go into a specific concept in graph which is called as minimum spanning tree, which will be very helpful for us to compute the minimum cost in a specific tree. Right. Now let us explore about minimum spanning tree. So before we venture into the algorithms that are present inside the minimum spanning tree, we should know what is spanning tree and why it is minimum spanning tree. So let us speak first about a spanning tree. Right. As you know, we are speaking something about graph, but here I am telling something as a tree. Why it is so? Let us take an example like this. I have 4 nodes, right. So these are the 4 nodes that are present in this specific graph, right. And this specific graph is a undirected graph because there is no flow of direction. The flow can be in both these sides. Now I can redraw this graph into a tree. What we know about tree, or what is the difference between graph and tree? Graph contains a closed loop, whereas tree will not have any closed loop. So there will be no cycle in tree. So I am going to convert this specific graph into a tree representation. Let me show you one specific representation of it. A. So from A I can reach B, and from B I can reach C, and from C I can reach D. Now we know this graph is having 4 nodes, and I visited all those 4 nodes by starting from A, like A to B, B to C, C to D. So this is how I reached all the nodes. Our objective is to visit all the nodes, right? So I have visited all the nodes, but this is not having any cycle. There is no cycle here. At no cost it is having a cycle. So it is looking as a tree. Since there is no cycle, this is looking as a tree. The same way, there is one other possibility to do this, like from B to A, then D, then C. This is also one other way to represent this graph as a tree. Here also we do not have any cycle. Here I have followed a path like this, B to A, to D, and then to C. Likewise, I can go on drawing some sort of tree representation which is not having a cycle. This is called as spanning tree. This is called as spanning tree. Now let us recreate this graph having with some edges like 2, 1, 3 and then 2. Now this graph is having a weight, right? Now let me put a weight over here like 2, 3, 2 and here it is 2, 1, 2. Now I have drawn the spanning tree along with its weight. Now let me compute the total cost. So speaking about the total cost over here, I am going to add all these things, the path, right. So here I had 2, this is 3, this is 2. So 2 plus 3 plus 2, this is nothing but 7. Right. The same way here I am going to compute the total cost. So total cost for this spanning tree. So here this is 2, 1, 2. So this is 2 plus 1 plus 2, which is 5. As of this example is considered, I have taken only 2 spanning tree, but there are n number of spanning trees, right? There are n number of spanning trees. Out of that, I am considering only 2 spanning trees. And here, on taking these 2 spanning trees, I have computed the total cost of these 2 spanning tree. Like the first spanning, let me take this as ST1. So this is the first spanning tree where I have obtained the total cost as 7, and this is ST2. So where the total cost here is 5. Out of these 2 spanning tree, I have found that this specific path is having a minimum cost. This is having 7, whereas here we have 5. So this is having a minimum cost, and thereby this spanning tree is called as MST, minimum spanning tree, as this specific spanning tree has the cost comparatively lesser than the first one. Likewise, you can explore the different spanning tree for a given graph and you can find the minimum cost. But just imagine if it is going to be a very big application. Let us take a Google map. We do have a plenty of cities, plenty of places where each and everything are connected together. In that case, if you are going to compute the minimum cost, how are we going to do? So to support this, we do have 2 algorithms. One is Kruskal'S, then second one is Prim's. Kruskal'S and Prim's both can work with the weighted graph as well as unweighted graph, and both are greedy algorithms, right? But the difference between those two are, Kruskal'S algorithm will work with edges, taking the edge into consideration, whereas Prim's will be working with nodes. So having with this, all these base, now let us explore about the Kruskal'S algorithm. So as I said, Kruskal'S algorithm is going to take edges into consideration. So let us take this specific graph. Now in order to solve the Kruskal'S, what I am going to do is, I am going to follow the main 2 steps. One is, I am going to construct the edge table. I am going to construct the edge table. Then I am going to sort based on weight, right? And then of course I am going to create the tree. So construct the edge table, sort based upon the weight, and then you are going to visit if there is no cycle. So you should ensure that there should not be any cycle, because the first and foremost constraint of a spanning tree is it should not have any cycle. And the second one is it should have a minimum cast, and hence it is called as minimum spanning tree. So looking into Kruskal's algorithm, we are going to take all these 3 steps into consideration. So let us go into step 1. So step 1, as I said, we are going to construct a edge table. So let me have the edges and then cast, visited or not visited. So here I have the edges A to B, B to C, C to D, and then D, E, or let me write it like this so that it will be very easy for you guys to understand. A to B, B to C, C to D, D, E, and then E, A, and then we have B, E. So I have listed all the edges. We can cross check. So 1, 2, 3, 4, 5, 6. So I have 6 edges and I have 6 entries over here, right. So now let me put the cast of all these things. Okay. So let me have the cast. The cast from A to B. So on reaching B, the cast taken is 1. Then for BC, so BC the cast is 3. For CD the cast is 4, and DE has the edge with weight as 6, EA takes the weight as 5, and BE has weight as 2. So this is what the first step, that is the step to create the edge table. So we have created the edge table. Now we are going to move to step 2. Step 2, as I said, we are going to sort it. So let me sort this edge, and this is going to tell about cast, and this is going to tell about visited. Okay, so this is a sorting step. Now out of all these cast, we have the cast of AB as very small. So let me take AB, and then I have BE with cast as 2, and then BC with cast as 3, and then CD with cast as 4, DE with cast as 6, right. So let me put here EA with cast 5, and then DE with cast as 6. So simply I have sorted the edges based upon the cast. Now after doing this, so I have completed these 2 steps. Now I am going to do the last step, which is visiting the edges. So in order to have this, let me erase all these content, and as we know, we have the edges. So let me draw the edges like this, C, D, E. So I had 5 different edges, so I have drawn all those 5 different edges. Now I am going to take edge by edge. So we are going to take edge by edge, and we are going to see whether the edge can be drawn or it is going to make a cycle. If it is not going to make a cycle, then only we are going to visit it, otherwise we should not do it, right. So we will start with AB. So this can be visited. So from A to B, we have cast as 1. Then BE. So BE, on drawing this, there will be no cycles. I can give here as 2 for AB, sorry, BE. Then BC, which is having the cast as 3. On drawing the edge between BC, it is not going to make any cycle. So I can draw the edge between BC as 3. Then CD, So, on marking CD, it is not going to make any cycle. So, I can go with marking CD. As of this example is considered, every vertices are visited. So, we can stop over here. Otherwise, when we go with EA, so speaking about EA, if I am going to draw an edge over here, this will lead into a cycle. So, we should not go on with this specific edge because this is leading to a cycle, right. So, unless another the nodes are visited, we should go on doing this, ensuring that there is no cycle forming in this specific spanning tree, because this is a spanning tree which does not have any cycle, right. And once the edges are visited, all these are not considered. Why these things are not considered? Because we have visited all the vertices. So, as I said you, in case if we have not visited anything, for example, if we have here if we do not have here the edge, right, and we are going to map here, this will frame a cycle, right. So, in that case we should not go on building an edge between E and D. Right. So, this is how Kruskal'S algorithm works. So, let me recollect how this Kruskal'S algorithm works. So, given a graph, we are going to follow 3 different steps. One is we are going to take the edge and build the edge table. Once this edge table is built having with edges and cast, then we are going to consider the edge table is sorted based upon the cast, and after sorting we are going to take edge by edge and we are going to draw the edge and we are going to check whether there is a formation of cycle. If there is a formation of cycle, then those edges are not considered. We are going to move to the next edge, and once all the vertices are visited, the process will get terminated. So, this is how Kruskal'S algorithm work, and these type of algorithm are highly helpful in order to find the shortest path. So, in this video we had a discussion on what is graph and how this minimum spanning tree is being built, and then we spoke something about the Kruskal'S algorithm where edges are taken into consideration having with 3 different steps: building an edge table, sorting the table based upon the edge, and finally marking each and every edge based upon the constraint of spanning tree, that is formation of cycle. Once this is being done, then the total cost will be computed here. So, total cost of this specific spanning tree is 1 plus 3 plus 2 plus 4. So, 1 plus 3 plus 2 plus 4, this is what the cost. So, having with that, the cost of this specific spanning tree is 10. Hope you have understood the working process of Kruskal'S algorithm. In the next video, we will be discussing about how Prim's algorithm is working. Thank you.